record this. Here we go. Here come some more people. I just had to wait another minute. As you guys come in, let me know if you have any questions. I have a couple of things to point out, and I'd rather do it when I have more people who are going to be here today. All right. So let's do this. So let me show you something I've put in Canvas. So number one, quizzes graded. Take a look if you haven't yet. Let me know if you have questions. Number two, grades updated based on your quiz grade, right? And I did, oh, here comes other people now. So I did remember to take off the lowest quiz grade when I recalculated your grades after that last quiz. So look at the quiz. Let me know if you have questions. Look at your grades. Let me know if you have questions. And then finally, I think it's finally, hold on. If you look in Canvas right now, tell me if this makes sense. If you go to modules, oh boy, here comes more people. Here's your practice final stuff. And then here's this, finals week Zoom meetings. So does everybody understand what's happening Monday? What's happening Monday? You guys know what Monday is?
Memorial Day.
Yes, so don't come to school on Monday. All right, I like it. Monday's a holiday. Enjoy it, celebrate by doing statistics. On Tuesday, I'm gonna have general office hours. Do you see here? My general office hours on Tuesday will go from 1 to 2:30. Zoom link will be put here later. I like that. All right. You guys with me so far? So I will have general office hours for all of my students Tuesday 1 to 2:30. And then our final exam is on Wednesday. And if you click on the June 2nd, Zoom link will be put here over the weekend. Office hours from 12:30 to 1:45. The final exam starts at 1:45. Everybody with me? Do not be late. Log in early. Unless you come to office hours, in which case you're early. I will be shutting the class to people after about 10 minutes have passed once we start the final, because if you come that late, I have no idea if you've already looked at the final and started doing some stuff without me knowing. So that's not good. So don't be late. If you have technical issues, get in touch with me. I will work with those as need be. Everybody understand? Suggest when Tuesday comes, come to class early, just to make sure everything's good. Okay. Any questions over all that stuff I just talked about? All right. I know we're all tired. Is anybody not tired? All right, that's what I thought. We are all very, very tired. My God. But we're almost there. We're so close. So today is all about whatever the hell you want to talk about. We've got the practice final. We've got the last quiz. We got all the quizzes. If you're doing corrections on quizzes, we got the midterm you can make corrections to. So you can ask questions of practice final, from homework, from quiz corrections, from the midterm corrections. Anything, right? Today is wide open. There, the floodgates have opened now. Look at all the questions come flooding in. You can put them in chat if you have a question. If there are no questions, I'm just gonna leave because I've already made the practice final video. Right? Are you guys okay? You guys gonna be okay? Is anybody? Have you changed the channel? I think somebody's changed the channel. They're like, this guy's boring with Mars behind him. I'm gonna watch Netflix. I understand. Okay, all right. I don't know if you believe me about this. I have nothing prepared for today. Zero. I have nothing. It's completely about your questions. I hear somebody. Okay, now I don't hear it. I love you guys so much. All right. I don't know.
Can we go over question number 3 from the practice file?
Yeah. All right, let's take a look. Dooby. I'm so excited. I got a question. All right, let's see. Number 3, this guy?
Yes.
Yes. Okay. So don't forget, I actually will be giving you a formula sheet attachment to the final. Everybody with me? So I will provide you with the formulas you need. You're not allowed to use notes or anything of your own. All right. But I will provide you with all the formulas. So more than likely on number 3, you're going to want to use a formula that involves X and P of X, right? Okay. Now, what part of 3 do you have a question about? Or the whole thing, or?
Yeah, can we just go over the whole thing?
Okay. What 2 things do I have to show somebody to prove it's a valid probability distribution? What 2 things do I have to show?
And it has to be greater than 30, but it's not.
No. Stop. Is there anywhere in here besides right there where it says the word normal? I didn't say show me it's normally distributed. It is very obviously not. Do you see how the highest peak is at the end, not in the middle? Right? What's got to be true if I have a bunch of probabilities for a situation? What do they all have to add up to be, for example?
1.
Or close to 1, right? Remember that crazy problem I made where it's 1.0001 or something like that? And you're all like, oh, you guys are so like, it's not valid because it's not exactly, oh boy, calm down. Jeez, you guys are, rawr. All right. What else has to happen that's almost too obvious that you don't even remember to say it? All the probabilities have to be between
0 and 1.
0 and 1. So just check both of those things. Check to make sure that, do these add up to be 1 or close to it? Yep, they do. They have to be 1. Check. So you would say all the probabilities add to 1. Check. Are they all between 0 and 1? Check all the probabilities. Right? All the probabilities are between 0 and 1. That's where they have to live, correct? I can't have a higher probability than 100%. Is that cool so far? Does that sound familiar, or does it make sense, or both?
It sounds familiar.
All right, does it make sense?
Yes.
All right, and again, your answer to that could be no. It's fine. I'm okay. I can take it. And then you got this question right here. There's a shortcut to this question. What's the probability that X equals 3?
.11.
Good. So does somebody see a shortcut to see what's the probability X greater than 3?
Oh, it's everything after .11.
It's the rest. And what's left after 11%? I love you guys. So one way you could do it is just say again. Yeah. If that's 11%, what's the rest got to be? 89%. Yeah. Or, it's not that big of a shortcut because the other thing is just to add these. Is that cool? If I just add those, I will get the probability of X greater than 3. Are you guys with me out there? Okay. I do worry about you guys. Academically, psychologically, all kinds of ways. All right. Now again, you are going to have a formula sheet to look at. So all you got to do is find the formula that's actually references what we know. It kind of makes sense. Does anyone know the formula I'm going to use for part C to find the mean? No? You
Just
guys-
add everything up and divide it by the mean.
No, definitely not.
X times P of X.
Yeah, so I've got to do X times P of X. The formula that I want to use is the sum of X times P of X. Does that, remember expected value? EXP. Now again, that'll be sitting up there on the formula sheet for you. So on the formula sheet, you'll have this little thing, and you'll have this little thing. Boy, that's really rough, Jeff. I know. Hold on. I thought I was running out of room, but it wasn't. All right, here we go. This, I don't know. Do these look even like the slightest bit familiar? I just want somebody to go, are you sure you lectured about that? I know somebody's thinking it. All right. How are you doing, Ethan? Is this, so remember how I lectured about formulas with the summation symbol? Cover this up, and then you see what you need.
Sorry.
That's all right. I was like, I don't speak dog. I don't know if I could help him out. If you cover the summation symbol, you'll see what you need to figure out so that you're able to add them up, because that's what the summation symbol means. You guys, I don't know if you remember me saying that, but if you have a formula with a summation symbol in it, cover the summation symbol up and you know what column you need to make. If the mean is the sum of X times P of X, I got to first make a column of X times P of X before I can freaking add them up. No?
That makes sense.
Okay. And of course, what does this formula need? It needs a column of X squared P of X's. So then I can add them up and put that number there and then figure out what the hell that is. Coolness. Kindness, yes. So then, I mean, 0.33, what is this, 5.6? Is that what that is? 0.6, what is that, Jeff? You could do it 7.8. And that is going to be 3.5. And then you add all that up, and that's going to be the mean. If you add up all that stuff. Okay. Now I'm all right. I'm not going to necessarily do this whole thing because it's on the solutions video, I believe. Unless there's more specific questions about how to continue with this. Is that all right? Is that all right? Anything else about that problem? Or I really want today to be productive, guys. I really do. And if you're uncomfortable asking a question, just privately chat it to me. That's fine. I can handle that. Anybody need more from this? Is that enough for this? Anybody have other questions from anything ever done in this class this whole entire semester?
I'm still having trouble with like the R values and what they mean and stuff like that.
Okay. So on the quiz, there were two questions there. One was interpret R. And that's where you tell me if it's weak negative or strong positive or some other combination, right? That's what interpret R means. The second question was, what does it say about the line of best fit, right? So there's, are you guys, is that basically what your question's about? That question?
Yeah.
Okay. So a lot of you guys answered the first question, but never answered the second question. If I have an R value of 1, what does that say about the line and the data points?
Very strong.
All right. That tells me the correlation for the data is strong, strong positive. In fact, not even strong. It's more than strong. It's perfect. right? What does it tell me about the line of best fit? You guys can do it. What does an R of 1 mean about all the data points?
That's perfectly aligned.
Good. So the data points are all on the line, right? Now, what if R is 0.9? Are all the data points on the line? Are they really far away from it?
No.
No, there you go. So what does an R of 0.9 tell me about the line of best fit? It's really close to the data points. So that's one way you can answer the question, is that the data points are tight to the line if the R is 0.8 or 0.9 or something. Another way to answer the question is, if I have a good R, I trust the line to make predictions. And that's why the very next question I ask is, make a prediction using the line of best fit, right?
Oh, okay. I get it now.
All right, I got one. Woohoo! That's a win. You got to understand, math teachers are like, I got 1 out of 30 something. That's a win. If you still don't understand, it's okay. Just ask follow question. I'm not expecting everybody to understand the minute I explain it once.
I need help is the last 2 questions for that quiz I didn't fully understand.
Oh, yeah. Okay. Part E was an opinion thing with 2 parts to it, right? So as long as you answered both questions, it would be really hard to lose points. So the problem a lot of people had was they didn't answer both, or they didn't answer either one really. So why does this court, now listen. Okay, this drives me a little insane. So let me say this. You ready? If I get pulled over for speeding, right? You with me? I get pulled over for speeding, and the cop comes up to my window and he says, "Why were you speeding, sir?" And I say, because the numbers that my speedometer were pointing to was big. Does that answer his question? Why were you speeding, sir? Because the
No, it
numbers.
does not.
Sorry? Go ahead.
I would say no, it doesn't.
No, it does not. So if I ask you, why does this correlation exist? And you say, because the points lined up good. No, that's how I know that a correlation exists. Why does it exist in the physical real world? Why would there be connection? Now, listen, I want to address the uncomfortable issue here. I think some of you guys probably know my politics. The data is the data. And the data does not mean that dumb people voted for Trump. That's not what the data means. There's a lot of different, is school the only way to get a good education?
No.
Hell no. In fact, I very often say, don't let school interfere with your education. Obviously, I think that it has a big part in some people's education. I teach in it, so I probably believe in it, but don't let it get in the way of your education, right? That's not the only way to get educated. So for example, why does this correlation exist? Maybe the concerns that one candidate addressed resonated more with people that had certain degrees. That doesn't mean they're smart. It doesn't mean they're dumb. It doesn't mean anything. It just means they had different concerns. You with me? Does it make sense? So that's explaining why the correlation might exist. Now, would I accept the answer if you said something like, well, because the more educated you are, the more you vote Democrat? I would accept it because that's answering the question, but that's not the only possible explanation. Are you guys with me out there? I'm still waiting. Anyway, I have gotten a little bit in trouble with students with this question before, but it's just numbers. It's just numbers, and it doesn't mean what some people think it means. Now, the second part of the question was, why is California an outlier? And again, there's a ton of different answers you can give. What makes California different? Is there anything that makes California different? So you have to tell me, in the physical real world, why would California have voted for Biden more than was predicted, right? It's almost impossible to get that answer wrong if you actually answer the question. Is everybody with me? Because it was an opinion question, but I want to make you
So-
think a little bit. Yeah.
An example of an answer would be like correlation exists because more people preferred Biden.
No,
No.
that explains why he won. And if anybody out there doesn't think that's true, don't bring it up right now, please, to God. I can't take it right now.
I'm just trying to wrap my head around.
No, you're fine. No, I'm not trying to do
Question.
that. Just in case anybody else out there listens to letters of the alphabet like you or something, keep that shit to yourself. Now, that would explain why he won. That doesn't explain why there totally is a connection between how educated in the school system a person is and whether or not they would vote for Biden, right? There is a connection. Why would that connection exist? And again, I already gave one possible example, didn't I? People that have gone through the educational system might have different concerns than people that have not. People have gotten their education in other ways might have different concerns than people that got it the textbook way, right? Does that make sense? Why do you vote for one candidate over another? Primarily, it's because one candidate speaks to your concerns, correct? You guys with me? No? Do you guys not agree with that? Do you just vote for the one that's first on the ballot all the time? So you can get that little I voted sticker? Is that how it works? Sorry, I don't want to get too personal. I want to ask how you do things. Does that make sense though, what I just said? I mean, that is one possible answer that I'm probably going to get on a lot of corrections now, but too bad for me. There are other possible explanations that I would accept all day long because you're just offering a possible explanation. Does it have to be the reality? No, it's just a possible explanation, right? Does that
I
make
think
sense?
I think I was more concerned about giving you a mathematical
Yeah,
response, and I think other people were too. It's like, how do I
a
make
lot of
this
people were
math?
doing the calculation when I already gave you the number that the calculation would lead you to. So that's fine. I like that. You're just kind of like, I took that as you're making sure I was speaking the truth when I told you the number.
I was confused too.
So that is you guys have got to let go of that. This is statistics. Not every question I ask you is going to be mathematical. This is an opinion question about the way the world is, right? And that's what statistics is. You start with the data, and then you got to figure out what does that mean in the real world? What is this? What do these numbers mean? What do they tell me? Or what might they tell me? And then it can set up more tests to see which one of those explanations is true. Yes?
And this trends us over to question F, right?
Yeah, question F is the big one. If I see a connection between two things, does that mean that one thing causes the other one to change?
Yes.
No. If I watch a bunch of people playing basketball and I think, oh, playing basketball makes you taller, is that true? Isn't there a connection? Wouldn't you agree with me that there's a high correlation between playing basketball and your height? Would anyone disagree with me? I'm assuming that means everybody agrees with me, right? So don't come at me with, no, I knew this one guy. Remember Muggsy Bogues? All right, there are short people that play, but overall, isn't there a connection between height and playing basketball? Yes. Does that mean that playing basketball makes you taller?
No.
That's bullshit, right? Obviously. So now obviously it's more the other way around probably, right? But again, a correlation study just finds a connection. It does not explain any causality. It doesn't say that this causes this, right? Sort of like there was that one that we didn't do, I don't think, but it was a study between the percentage you have a bachelor's at least and the median income in a state. Stay with me now, guys. Obviously, people would say, well, you get a higher education, you get a better paying job, correct? That's what most people would say. Isn't it also possible that if you make more money, you have money to go get a degree? Couldn't some people, if they make enough money, they go get a degree? Yes. So isn't that a possibility that some of it was the other way around? I have no idea if you guys are still with me or not. So yeah, that last question is really summed up in a misunderstood statement. Correlation does not imply causation. Just because two variables are correlated does not mean that one causes the other one. So like if I found a correlation between eating eggs and lower blood pressure, you should not go out and start stuffing eggs down your throat, right? It could have been the other way around. Maybe lower blood pressure makes people want to eat eggs. Do you guys understand what I'm saying? Is it likely that second explanation is the truth? No. Is it possible? Yes, it totally is possible. Who knows? Lower blood pressure, I'm like, man, I want some eggs. It's not impossible. That's a possibility. I don't know. All right, I'll shut up. Any follow-ups on that? So those last two questions definitely gave people trouble because they were the conceptual questions. Anybody still not feel good about those last two, or what's up? You guys all right?
I have another question on quiz 5, if that's all right.
No. Yeah, it's fine. Hold on. Let me look it up. Quiz 5. All right. What are we looking at?
Question 2, letter II, or the Roman numeral, if that means.
So on everybody's quiz 5, number 2, part B, was the central limit theorem, right? It was where I was talking about height of people, and on part B, we take a sample of so many people. And then I ask a question about the sample mean. So isn't that where I have to change the standard deviation? Divide the standard deviation by the square root of n, right?
Yeah. So I got my new standard deviation, but it's just on the probability that the sample mean is more than 71 that I'm having problems.
Look at 2A1. The very first problem in number 2, right? Isn't that basically the same question?
Yeah, but I got like a super weird standard deviation.
Oh, all right.
I got 3.558.
No, because you're all right. Wait a minute. What was the original standard deviation?
The original was 3.07.
All right, so there's no way it can get bigger if you're going to divide it by the square root of the sample size. There's no way it can get bigger, right?
Right.
Would you divide that 3 point whatever by?
I did 38.5 divided by the square root of 52.
Whoa. Okay, that's way off. So you take the original standard deviation divided by the square root of the sample size. That is the new standard deviation. Sigma divided by the square root of n. So you take your
Okay.
3.07, I think it was, divided by the square root of the
50.
sample size.
Oh, okay. Well, then the rest of it is right. I
Okay.
got it. Thank you.
You're welcome. Yeah, so your sample, your new standard deviation can never be bigger than the original one because you're dividing it by something bigger than 1. Yeah. I like it. How's everybody else? So again, you can ask questions from corrections like Ethan just did. What's up, Wasan?
Yeah, I have a question about when it's like when you are saying it's normally distributed, like what's the evidence that it's like that? Like I always like get confused when it's like not the z-score, it's the t-score.
Oh,
What I should write for that?
all right. To use a z or a t, it has to be normally distributed.
So it's always normally distributed, like anyway.
If I'm going to use, if I have a problem about the means, so I could use a z or a t, right? Depending on which standard deviation I know, they both require a normal distribution to do anything.
So if they are not let's say the sample, it's not 30.
Good.
You know, so what I should write if it's not 30?
Real quick. In the book, every now and again, there's a section in the book where they say all the t-score problems are normally distributed, and then the very first problem is a z-score problem, and n is less than 30. So technically, if you have the gumption to do this, you could write, it's not normal, n is not big enough, cannot do this, and then keep going. Right?
Oh, it's
Now-
not normal. It's not big enough.
If
And
it's
we
not,
have to use this score.
yeah, no, if it's not stated to be normal and n is not greater than 30, technically you cannot do anything.
But you always like state like it's normal enough. I get confused. Like,
If n is greater than 30, then it's normal enough. When I plot the means, that becomes normal enough.
oh, okay.
And what I mean by enough is it's not going to be perfectly normal, but it's normal enough to use the chart to get the numbers.
Oh, okay.
They might
That's
be
what you mean.
off in the 18th decimal place, but we only go out 4 places, so it's normal enough.
Okay.
But if
So
n
you-
is not greater than 30 and it doesn't say it's normal,
Mhm.
I technically can't do anything. Now, what did I say to be careful? I said, you can say, I don't think this is normal, but then you still do the problem. Because either you're missing something, right? Or you still do it because you need the practice.
Okay.
Does that make sense?
Yeah, I was confused because you didn't like do my chapter 9, I think. You didn't like correct it, so that's why I was confused. I did that in my homework.
Okay.
I had the same problem, but what I didn't have correction for that to see.
Yeah,
if
chapter
it's
9 is
wrong.
where the book really starts to get a little loose with its
Yeah, and it's almost like half of the chapters that you had, it's like the distribution and the t-score and the z-score, like a lot of that, and it's how it's normally distributed when it's n greater than 30, and also like the NNP, it's
Yes.
greater than 5.
percentages, yeah.
Mhm.
P and NQ have to be at least 5, yeah. Okay. I like it. But again, what's the main determination between Z and T? If I know I have a normal distribution, what tells me I can use Z? What tells me I have to use T? When am I allowed to use Z score?
If you have sigma,
Good. If I know this population standard deviation, I'm allowed to use a Z score.
Mhm.
If I only have the sample standard deviation, I got to use a T score. I like it. There you go.
We could say that mostly, like we could do that.
Well, I mean, again, it's got to be normally distributed, either because it says so or because it passes the test n greater than 30 or NPNQ greater than equal to 5. Right? But then if it's a means problem, you got to, which standard deviation do you know? That's what tells me to use a Z or a T. Yeah. Okay. Anything else, guys? You got to balance needing to know how to do stuff before the final gets here and wanting to not be on Zoom. You got to find the balance there. Ethan, what you got? Oh, you're good? Okay. So floor is all yours. If you have a question, nobody else is asking anything right now. I feel like a lonely YouTuber with the lines open and nobody's calling me.
I have a question on number 9 for the practice final.
Let me turn my Bernie on. Number 9. Oh. That's exciting. Did you guys hear that? Giving us formulas, will you also get the ZT score charts? Oh, I will attach ZT and chi-square charts in case you can't find yours or whatever. They'll be attached on the final. Can you guys hear that? Good Lord, what's happening out there? There's a boat coming through. That's weird. Pretty inland.
That's Bernie's phone.
Huh?
That's Bernie's phone vibrating.
What do you want from me? Oh, turn it down to 1%. Okay, you're only 1%. You need a charger. All right. Where am I at? So I'm sorry. You just asked me a question. Too much happened in between the question and now. Number 9, maybe?
Yeah, number 9.
All right, thank you. Let's see. Oh yeah, okay, shit. I forgot to say this. All right. I think I did this did I do this on the solutions video? Did anyone watch those? Didn't I say that this was like an extra credit? Because this is from chapter 10, section 10.2, which I did make that extra credit, right? Yes, I did.
Is it a confidence interval question?
No, it is a hypothesis test. Test the claim that the mean scores are the same. So it's a hypothesis test. But it's from that chapter 10 it's from section 10.2, which is extra credit. So if I put a problem like that on the final, it will be a bonus question. I will give 3 bonus questions on the final, just like always. Or I mean, just like on the midterm, I guess, not always. Think about back when I gave 3 tests instead of 1. All right. Is that all right? So you don't have to worry about this one, and it's bonus. So I would only try it if you actually did chapter 10 homework. Yeah, let me see. Okay. So I answered that. I don't know if you guys really believe me. I'm just gonna sit here.
I have a question.
Oh, okay. What's up?
Well, I mean, would it be a good idea to review the midterm and every practice for the midterm for the final, or
Yeah.
Okay. Is it going to be that cumulative?
I mean, so all right. So you can make it a part of your study. Could be looking at the practice midterm and the midterm itself, sure. But obviously that only goes up halfway. Then you can look at the quizzes after that. Sure, that's not a bad idea.
Okay.
I like it.
If we're finding a probability, if the probability that the sample mean is more than 71, but we only know the sample size, do we have to make a new sample mean somehow?
Whoa. Stop it now. All right. You know the mean, don't you? Didn't the beginning of the problem tell you what the mean was?
No.
Yes, it did. You're still talking about quiz 5, right?
Yeah.
What's the very first sentence tell you?
If we take a sample of 52 ostrich.
No, stop. The very first sentence in that number, you're doing part whatever, right?
Oh, 70. Okay, so we can use that.
You have to. In fact,
Okay.
so that's the mean of individual people. What would the mean of all the sample means be? It would be that, right? Just because I take them in groups doesn't suddenly make them all older or something. The mean should come out the same. So the mean of the sample means is the same as it was before. It won't change just because I take people in groups instead of individually. Yeah. So mu is still the original mu on part B. Okay.
All right.
I like it. I like it a lot.
There's a number 9. You would always ask this question. I get confused sometimes what to answer. And is what would a z-score of 2.14, 14 tell us in general?
Yep. That's the one that's going to drive me insane a little bit because I told everybody the answer. So, all right, don't take this.
Maybe I didn't listen at that time.
Don't take it personal because
Okay.
you're in company of over half the class doesn't quite get that answer correctly. A z-score tells you the number of standard deviations from the mean to the data point. So if I had a z-score of 2.14, whatever it was, that would mean that data point was 2.14 standard deviations away from the mean. Done. That's all a z-score tells you. So for example, if let's say I make an m-score. An m-score is the number of miles from the school to somebody's house. And if my M score is 11, that means I'm 11 miles away from the school, right? So a Z-score is just the number of standard deviations away from the mean that something is.
Oh, okay.
That's it.
How
Yeah.
far is from the mean? Like,
In standard deviations, yeah. So like an M score could be how far from the campus I am in miles. A Z-score is how far away from the mean something is in standard deviation. So 2.14 Z-score would mean that that data point is 2.14 standard deviations instead of miles, standard deviations from the mean. Or even better, above the mean because it's positive, right? But you could just say away from the mean, that's fine. Is that okay?
Mhm.
So if I have a Z-score of negative 1.7, that data point is 1.7 standard deviations below the mean.
thank you.
What?
The man behind you is distracting me.
Oh, I'll start him off. Hold on. He's distracting. Right, Vern? Sure. All right, it's okay. Here, what about that? Sorry. Let's see. I'm just gonna play around so somebody asks me a question. Let me see here.
I have a question.
Yes.
Oh my god, that's so funny.
Bernie has mutated. I want to see a llama with Bernie's accent. I like that. 1% of the llamas. All right. I know it's llamas. Be quiet. So what's up? Sorry.
It's from chapter 5, question 13.
All right, chapter 5. All right, there we go. Oh, so this is really, so this problem is just find the area of this.
Mm-hmm.
Yeah. So how long is it?
The shaded part, 5,
And how tall is it?
1/8.
Good. So how do you find the area?
Multiply it.
Yep, and that's it.
Okay.
So the whole idea, this is what led us into the normal distribution. The whole idea, if I graph a probability distribution and make the whole area 1, any probability question is equal to the area that question makes. So if the question is, what's the probability it's from 0 to 5? If I find the area of that, that's the answer. And I was talking about dartboards. I don't know if you guys remember dartboards, and it's harder to get into the little bullseye, and that's why it's worth more points for a lot of different versions of the game. No, yes, maybe, no, yes, maybe. So surely if I can get in that bullseye repeatedly, that is good evidence that I can throw a dart really well, right? Because it's difficult to do that randomly. It's a little tiny area. So the area of something is equal to the probability of something falling in that area. That's kind of neat.
Could you go over the 5-number summary?
Yes. Let me see. Yeah. Does somebody know what the 5-number summary is?
Is it the 25th percentile?
Yes. So I'll start it off. It starts off low, and then Q1, 25th percentile, and then
Q2, 50 percentile. Q3, 75 percentile, and then the high.
yes, cool. I like it. So low, Q1, Q2, Q3, high. Is that all right? Who asked that?
I got it written down. Thank you.
All right. So guys, anything that has not made sense this whole semester, or anything that still gives you trouble, or specific question on a correction you're making right now that people have brought that up, obviously. So it's wide open. If nobody's asking questions, you got the floor. You guys don't like that? Okay, well, I mean, I didn't bring anything except backgrounds. So. Let me see. Where are you at? Can't find my favorite background. Oh no, it's not there anymore. That sucks. Man, shit. It's all right, Jeff. I like that one. I'm seriously just going to do this for the rest of the time. So a sample question could be, I don't understand chi-square shit at all. Could you do an entire problem like that, Jeff? That's a sample question. I don't remember probability. Can you make a problem up real quick about probability? Or it could be, I don't understand chapter 7, number 52, part F. So it could be general, it could be specific. If you are completely ready for the final, you could, there it is, that's my fear. You can head out, that's fine. Right? The whole purpose of today is getting ready for the final. If you are ready, oops, see, somebody already left. If you are ready for the final, then you don't need today. Was everybody here earlier when I showed what I added into Canvas for next week? Did anybody miss that? Hopefully just left. All right, let me do this before I lose everybody. So here's the plan for next week. I'm sorry, here it is. I have some general office hours on Tuesday, and then our final is Wednesday. Office hours start at 12:30. The final actually starts at 1:45, which is good. So if you get here on time, you'll be 15 minutes early, right? Because we normally start at 1:30. I always hate when the final starts earlier than the normal time. That almost guarantees I'm going to have somebody show up late. That sucks.
So no class on Monday, right? Just
Yeah, that's right. And by the way, this week is the last week of all your classes. Next week, everything changes. Everybody's on final exam schedule. You only have to meet for your final exam next week, right? So don't go to your Tuesday class at the Tuesday time. You only have to go at your final exam time. So hopefully all your teachers are making that clear. All right.
I have a question for your homework, 11.2.
11.2, okay. All right, I'm ready.
When we are given a percent and unexpected, those problems are not gonna be uniformly distributed, right?
Exactly, good. So you're talking about like number 73 maybe?
Yeah.
So this is basically exactly like that grade problem we did. Do you remember the grades problem where I thought this many would have an A and this many would have a B, or even the cholesterol problem where I thought this percentage would have this cholesterol. So here, now again, they've given us the information in all these different tables, but this is going to be, so to figure out the expected frequency, I expect 31.3% to have never been married. So I would do 31.3% of
Arrow came out to be 17.482. Yes. All right.
that was weird. That was like me talking to me. Wasn't that me? Holy shit. Am I going to travel through time at some point? All right, that's going to be awesome. And then I'm going to log into my Zoom meeting and talk to me. Okay, now coming back to this, I'm really sorry. Does that make sense? 31.3% of.
Oh, I couldn't hear anything. Sorry.
I'm sorry. Okay, I'll say it again. So we expect 31.3% of any group of men to have never been married. If we have a group of 400 men, how many do we expect to have never been married? 31.3% of 400.
Okay, so I divide those two, right?
No. What does of mean?
Do I subtract them?
No.
What?
Multiply. Right?
To get the expected frequency.
Yeah, so you always multiply percentage to find the amount that the percentage describes, right? So it's of means multiply in mathematics. So 31.3% of 400, I would do 0.313 times 400, right? So let me see, let me get it started here. So this would be 0.313 times 400, and whatever the hell that is. This will be a 125.2, I think, whatever it is. And then you do 0.561 times 400. Is that cool?
Yeah.
All right, so these will all be E, expected. Down here, they give you O, the observed. So if I were you, I would do this work and then I would start to construct my table, my own little table. I'd have O, E, O minus E squared, right? O minus E squared, O minus E squared divided by E, blah, 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 like we did on the chart, right? So the O is going to come from here. The E is going to come from this work. Yes, yes?
Yes.
Okay. So they kind of gave us, here's expected information, here's observed information. So when we start to do the problem, we're going to collect it all in the table. So I can start just going through it.
Okay, I understand. Thank you.
Sure. That's a good question, though. This is a little bit weird because they give it to us in two different kind of places. Okay. So this will be the observed. All right.
Oh, can you do also number 2 with the question 2, chapter 11?
All right, let's see.
It's kind of easy, but I don't know.
Oh, this is a reading problem, right? So you have to kind of read through the section. So you talk about this. If the degrees of freedom is greater than 90, did anybody figure this one out? If the
It's
degree,
normal, right?
yeah, good. And if degrees of freedom is 15, the distribution is skewed somehow.
Oh.
Yeah, so it talks about this, I think, even in the let's see, in the chapter review. Let's see, I think they put it here. Did they not? Well, I guess not. I'm a liar. Oh, here it is. Yeah, that's the part about the normal distribution. And then if it's not greater than 90, then it's its normal self. It's skewed to the right.
Oh, okay.
Job
Thank
of the
you.
Hutt. You're welcome. Job of the Hutt. All right.
Actually, on the quiz 9, so can you do the D also? So comparing to like data points.
All right. So you calculate the prediction using your line of best fit.
I did it, but the next one, the comparing is
All right,
different.
let me see. How can I say this? Oh, let's look at the practice final. That's a good idea, Jeff. I have those. Okay. Didn't I say something like this on the practice final? Hold on. Here we go. Did I? All right, here. So, I mean, all right, that's not a good example because I really didn't. If I predict the weight for somebody who lives half a mile, well, I mean, all right, what if I predict the weight for somebody who lives 1.5 miles? Am I going to get, the way I'm going to do that is I'm going to plug 1.5 into the equation. So when we calculate a line of best fit, we are coming up with a way to convert this miles to brown pizza in this case into an estimate for weight. So it's an estimate. So if I plug this value into my equation, it comes out with an estimate for weight. Then I can compare it to 216. I can see how good the prediction was. That's exactly what we do in the quiz. We take the number I give you, predict the percentage voting for whoever for a state with this bachelor's rate, right? Bachelor's degree or higher. You plug that into your equation, you get a number, and then you compare it to a state that actually has that bachelor degree rate. You see what their percent voting for that person was to see how good your prediction is. Makes
Okay.
sense? Okay.
Okay.
Maybe I should look up, let me see. Look up the quiz itself. Here we go. Quiz 9. Preview. Open Sesame. Okay. So like, well, I think it was Connecticut. I don't know which version you had, but I said for a state with 0.384, predict it. So you plug it in the calculator and you get a number. You want to compare that number to that, for example, or whatever state it was I was talking about, right? You have a predicted value, but you actually have a known value. That's the known value. And you want to see, they should be close because our R value was pretty good, right? Okay.
Thank you.
You're welcome. Yeah, a lot of people had trouble with that part. So I appreciate that question. And so should those of us who are still here. All right. Anybody else? Questions?
I have a
Stephanie.
question, but it's going way back to chapter 7.
It's a perfect time. I mean, we could take a question on chapter 1, number 1. Because that final is going to go all the way back. So which question?
It's from the homework. It's question 64.
All right, let's see. Suppose world-class runners are known to run a marathon. The average of that was John Redbecker, short 49, blah, 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 blah. Now, this asks, how are the sample means distributed? So let me ask you, how do you know this is going to be a normal distribution of means? How do I know this is going to be normal? Does it say anywhere that it's normal? Nope. So how do I know it's normal? What do we check for average? What's got to be true to know if it doesn't say it's normal? What's got to be true to know that it's normal enough? What do I check? Do I check? Nobody knows. This is for anybody. Anybody. Do I check NP and NQ to see if they're at least 5? Do I do that? Do I have a P and Q? Of course I don't do that. What do I do?
It is greater than 30.
So you have 49, and it's 49, which is greater than 30. Yes, 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 yes. We know this. We know this. So that's why I can put an N here. It's normally distributed, right? The mean will still be 145, but what will happen to the standard deviation? Will it still be 14? Nope. Don't have to change it because we took a sample of races and we're asking about the sample mean, right? Don't have to change this. Right? Anytime I take a sample and I'm talking about the sample mean, I've got to change the standard deviation to work for groups of whatever size, in this case 49. This is really nice, 14 divided by 7, so you get 2. Is that all right? Is that all right? And now the rest of this is just finding z-scores, right? You can draw the picture, you could put 145 in the middle, put those on there, make z-scores, look them up. Is that okay?
Yeah.
Okay.
Quick question. I haven't done the finding the z-scores, but how would we find the 80th percentile? Like, how would that go?
Oh, on the picture, where would the 80th percentile be? Would it be in the middle? Would it be over here? Would it be over there? Left or right? Middle?
Would it be like to the right?
Why? You're correct. Why? What does 80th percentile mean? What percentage is below it?
20.
No, that's above it. So there's 80% below it, which is why it has to be over here so that there's room for 80% below it. Do you see that?
Okay.
And then you look up the z-score, and then you can convert that back into a raw score. So maybe if I show you on the practice final, a similar problem, so you see how I like to set them up. Oh, where'd you go? Oh, there you are. Okay. Let me see, where were you? Yeah, here, very first problem, all about coffee. Kofifi. So the first part is normal, make a z-score, and then the second part, it took a sample and I talk about the sample mean, so I've got to change the standard deviation. So this is the way I like to do this. So it's pretty clear. This is the way I've always kind of done this for you guys. I don't know if you've noticed. Is that all right? So the book kind of, you know, does it in a little bit weirder way, but all right.
Can we go over one of the probability questions for the probability quiz?
Probability. Oh, the double quiz?
Yeah.
Yeah, okay. There he is. I'll stop. Look here. Oh, where are you? It was quiz 3, yes. Did you have a specific?
Yeah, I wanted to go over number 4A and C real quick.
Oh, okay. So now this might not be the same quiz you got, because not everybody, but there were different quizzes. But in general, you know, I'm not going to give you this exact question, right? But I could give you a question like this.
Yeah.
In general, if I give you information and then I ask you a question, here's the formula for probability A and B, right? Right? Are you with me? These two formulas, either one works.
Yeah.
Yes. Do you have enough information to calculate probability of A and B? Do I tell you what the probability of A is?
Yes.
On this example, right? Yes. Do I tell you what the probability of B given A is?
Yes.
Yes. So just multiply. You're done.
Oh, okay. I don't know. I had the hardest time with this one for some reason.
Part B is the other way around. There is no formula for probability of B, but there is a formula for this that I gave you, right? And it's right down here. And we know this from part A. I tell you probability of A from the beginning. I tell you probability of A or B, so then you can solve for this. So it's all about what's the equation for what they ask me or for something that they tell me. Because then maybe what they're asking me for is in that equation, right? And I got everything else, I just got to plug it in and solve. Yeah.
Okay. Yeah. For some reason, I don't know why I had such a hard time with this one.
Because this one is the algebra version of probability, right? It's not the count version, it's the algebra version. We have formulas, plug shit in, solve for the thing you don't know. Good old algebra. Good old algebra. All right. I have
Which one you said is the probability of B? I didn't get
Oh.
that.
Probability of A or B, the formula has probably B in it. See? All right, let me see. Shit, sorry. There we go. So the first problem is easy because there's a formula for this and it's right there, right? And then I just throw what I know in and I'm good. The second formula, there is no formula for probability of B, but there is a formula for probability of A or B, and it has probability of B in it. And I know this from part A. I know this because they told me, and I know this because they told me. So then I can solve for this. Right? I can solve for this because I know everything else. So that's what I mean by it's just like algebra, where I don't know X, but I know everything else. I can solve for X. You can even put an X here if you want to. Bam, I don't know you. I'm going to call you X. And then you can solve for X. Jeff, all right. It's going to make a stupid joke about your X's. I
I want to hear it.
Sorry? Oh, no, it was about math is one place where it's legal to kill X, but
I get the gist of it.
yeah, that's enough. Sorry, you can probably tell I've had some rough experiences. Everybody has. Now, anything else from the practice final or homework or anything?
Yeah, I have a question about that 12.5. It's the last question. I did everything. I put everything in the calculator, but when you correct it to me, it shows that it's wrong, and I don't know what I'm doing that's being wrong.
12.5, number what?
Yeah, it's 72.
And let me see. Oh, so one big thing. All right, so a huge thing is they tell me stories is independent, which means stories is X, which means this needs to be in list 1. And this needs to be in list 2.
Oh.
There you go.
Oh.
That's why you were getting like 5-foot tall buildings. That should be a concern, unless it's from Ant-Man when they shrunk the building down, then it's fine. But
That's yeah, I'm saying like I'm putting everything. Why I'm getting like wrong answer?
Yeah. It's a little evil. I mean, up to this point, they were putting this was L1, this was L2, and then this one they said, ha ha ha.
Yeah, I didn't. Sometimes when it's the words, I don't focus that much. I have problem with that.
I understand. I mean, it's a math class and you're not used to worrying too much about the words. I understand.
But you don't get it sometimes, like for me, not for everyone.
Oh yeah, I'm with you. Sorry, I'm just gonna play around. Nobody's got questions. I still don't think you believe me. I have nothing. Today's all about you and your questions.
Well, thank you very much. I'm gonna head out.
Okay, Nikisha. Take it easy. I'll see you next week.
Okay.
Or tomorrow. I still got my office hours tomorrow too.
Okay.
So, all right. Corbin, you're good.
Bye.
Bye.
Thank you.
You're welcome.
Can we go over? It's the same quiz. I'm just trying to touch up on this one. Number
Sure.
C for 3C.
3C. Oh, what'd you get for 3B?
3B. I put 0.212.
All right, maybe, I don't know. what's the relationship between at least one and none? We are talking about chapter 3 quiz, right? I mean, yeah, probability quiz, right?
Yeah.
Okay. What's the connection between the probability of none and the probability of at least one?
That that will be 0. No, wait. I'm confusing myself here. Hold on.
All right. So if somebody said, I think that nobody liked season 8 of Game of Thrones, how would you show that they're wrong? If they said nobody liked it, how would you show that they're wrong? Nobody likes season 8 of Game of Thrones. How would you show that they're wrong? Are you out there? Hello?
Yeah, I'm trying to remember.
No, don't even remember shit. Just talk to me right now.
By showing how many people disliked.
No, if I said nobody likes Game of Thrones, all you have to do to show that I'm wrong is find at least
One person who does.
yeah, doesn't that make sense? So then aren't none and at least one opposite situations?
Okay, yeah, I get it now. Yeah.
All right, so then the probability of at least one is 1 minus the probability of none, since they're opposite probabilities. So whatever you got for part B, you just got to do 1 minus that to get the answer to part C.
Oh, okay. Okay, I did this completely wrong then. All right, I gotta redo that one then.
Okay. Yeah, so part C is not its own thing. It's like based off of what you got for part B. There's no extra work to do for part C. Yeah.
I might, if I can, hit you up on tomorrow on your office hours.
Yeah.
Later.
See you. How's everybody else?
Professor,
Yes.
I have a question about my grades again,
Okay.
because I don't understand why is it that percent?
Why it says what? No, sorry.
Why is it that percent?
Why it says that percent? What? All right, let me look you up. Let me make sure your grades got in here correctly. All right, let's see. Kurla, there you are. All right, here we go. Oh, wait, quiz 9. Hold on. Did I grade quiz 9 yet for you? Oh, what was up with your quiz 9? Why do I have a 0 in there for you? Hold on, let me see. Right, because for some reason I have quiz 9 as 0 for you. Oh, no, I see what I'm looking at. I'm looking at the wrong thing. Good Lord, Jeff. Let's see. So what wait. So what are you looking at specifically?
Oh, so I'm looking at the total. Like I don't understand what it means.
The total. What do you mean total?
It's
Oh, I see.
33,000.
Hold on.
Yeah.
All right. So Canvas does not calculate anything correctly. And unfortunately, all right. So I see what's happening. It's like a 30 something, right?
Yes.
All right, that's bullshit. You go off of, so I got to figure out, I thought I turned everything off so it wouldn't calculate anything. You go off of what I put in here. So look here.
Okay.
This is nobody. This is my test student. But if you scroll all the way to the bottom, so ignore this, whatever's here. Look at these. These are the average grade, what you need on the final to pass. If all the homework's turned in, what you need on the final to pass. If no homework's turned in.
Yes. So which one of all of those would it count? Like, which one counts the most, or is it all the same?
No. So I don't know what counts the most means. So if you haven't turned in any homework, then this is the one that's more true. If you turned in all the homework, then this is the one that's more true.
Oh, okay.
Here. So if you're halfway in between, if you turn in half the homework or something, then you're halfway in between these.
Okay.
whatever they are for you. Yeah.
Okay. Thank
So I
you.
gotta figure out and turn off the other things so people aren't confused. Thank you for letting me know.
Okay. Yes.
Okay.
Okay. Have a nice day. Thank you.
Bye.